Okay, this is about a correction to the video I made on connecting a PC to a toy crane via an Arduino. If you haven't seen that video yet, please do. Now on to self-flagellation. Here again is the schematic that I drew up for the interface circuit. Surprisingly, it's actually right, I think. The problem was in the hardware configuration with the transistors installed on the breadboard. Here's how I illustrated the transistor configuration in the previous video, matching a schematic of a transistor with a SketchUp drawing of one. Problem is, it's wrong. The illustration should have been turned the other way to match the schematic, and that means that the transistors on the breadboard should have been turned too. And yet, what the heck? How can the circuit work if the transistors are turned backward? Let's check the transistor package. Yep, flip that illustration upside down and turn it 180 and it looks like this. So maybe it's time to put together a little test circuit. Here's a transistor with a green LED connected to its collector. The transistor is turned the wrong way, yet current is obviously flowing through the collector to emitter. Here's the same circuit with the transistor now correctly installed. The LED is still glowing, proving that transistors do work when correctly installed. There is a difference between right and wrong, however. It has to do with the ratio of collector current to base current, that K in the little equation here. Engineers refer to the current gain as HFE, which stands for Having Fun with Electronics, or Hawaiian Festival of Eggplants, or I don't know. Doesn't matter. Moving on. Anyhow, the bottom line is that when the transistor is correctly installed in the circuit, the current gain is much higher, which causes me to wonder. Recall those resistors that I put in front of the transistors to protect the Arduino pins from shorting out? Originally, I used 1K resistors as recommended by the Arduino.cc site, but then not enough current was going through the motor to turn it over. So I swapped the 1Ks for 220 ohms so that I could boost the base current and hence the collector current and provide more current for the motor. It worked, but after all this, I came to wonder what would happen if I installed the transistors correctly. With the higher gain, could I have used 1K ohm resistors after all? Well, here's the reassembled circuit. It's got brown, black, red 1K ohm resistors. It's got transistors looking from above like the letter C for correct rather than D for dumb. So let's sneak up quietly and run this thing. Happiness and joy. Yes, with the transistors now correctly installed, I can use 1K resistors to better protect my Arduino digital pins from damage. Now, it would be cool if I had intentionally reversed the transistors so that we could all learn a valuable lesson here. But that's not what happened. So next time, I'll read the package information first. Check out my blog at engineerzero.wordpress.com, and thanks for watching.